Welcome to the machine learning internship by Internship Studio. Proceeding further, we can look into the KNN algorithm. KNN is a K nearest neighbors algorithm. Basically, it's a classifier. So what it does is classification, and it's a very basic classifier. So what KNN basically does is it tries to see the similarity or the proximity of a particular sample. If you have a sample, in the sense like we have the training data that is spread across, and we have a new sample that comes into picture. What it does is it calculates the distance between the nearest neighbors. So what are the nearest samples that are present across that particular sample? It calculates the distance between them, and whatever the least distance you have, or whatever the samples that are nearby to it, belongs to particular class. Suppose we have a binary classification problem, in the sense like you have class A and class B, and first you have to choose the number of neighbors that you are going to choose, in the sense like suppose you have taken five different neighbors, so your k value is 5 here. What you are going to do is, once you have a sample that is projected into the higher dimensional space of the training data, we are going to search for five nearest neighbors, or going to calculate the distance between all these different neighbors, and try to take the five of them, and try to see which one is the nearest one. Out of it, suppose four are nearest. Class A, whatever the class A samples are there, four samples are near to it, and whatever one sample is there that is near to class B, one sample is near to this particular testing sample that we are using, or testing data point. Then what we'll conclude that this particular sample belong to class A. Why? Because you have four different neighbors, right, that are nearby, compared to one neighbor which is your class B. Roughly this is how KNN algorithm works. So it is K nearest neighbors that we are going to see. That is the reason we are the name itself suggests that we are trying to check the nearest neighbors, right? How many neighbors that we are going to check, that will be your K value. Yeah, so you can see right here. Whatever the similar data points are there, they are close to each other. These are the one class, these are samples belong to one class, these are sample belongs to one class, and these are sample belongs to one class. So if a new particular sample comes, then which class it belongs to, so you have to classify that particular sample into some class, right? We will use KNN to do that. And first we have to understand what is bias and what is variance. Bias is nothing but skewing. Your set of data will be skewed, which lead to the underfitting case. That is what bias does. And variance is nothing but you will be getting too many hypothesis results. In the sense like, if you try to, I think we have already discussed regarding this bias and variance part, right? If you have the spread of the data, right? So if you have a constant bias that is added to the value, then that is basically the bias. And variance is nothing but you don't have any additional bias or something that is added, but your result itself will vary with respect to particular threshold component. You have something like plus or minus n, right? X plus or minus n. That plus or minus n variation, whichever is there, that is called variance. So that is what. So instead of a direct target, if you repeat this particular experiment, it will be like slightly spread across. So as you repeat the experiment, the values will be spread across. So that spread is nothing but your variance, and that can lead to the overfitting part. So how we are verifying this bias and variance, in the sense like once we have the data set, we are going to divide our data set into training and testing data sets, and we will evaluate our training data set, and once the training is done, then we are going to test our data with test our model using this testing data, right? And will nearest neighbors have high bias or high variance? Whatever the nearest neighbors that we are taking into consideration in the KNN part. So they'll be having high variance. Why? Because every instance will be a hypothesis, right? In the sense, right, everywhere, every sample that comes, so every time, so there is no direct training that is happening here, but you have your training data that is projected, and once you have a testing sample that comes into picture, then with respect to the number of k value you have given, it will try to find the distance between those k number of neighbors, and that will be one hypothesis, right? Again, new sample comes, that is one more hypothesis. So that is the reason it's a instance based hypothesis. And the decision boundary is too detailed. Why? Because for every instance we are calculating the nearest neighbors, right? So yeah, so for some value k, take the k nearest neighbors of new instance and predict the class that is most common among the k neighbors, as we discussed, and elevates overfitting to a certain degree. So yeah, so as we take this k nearest neighbors, instead of taking the direct neighbors part, right, that we have discussed, if you use this k nearest neighbors concept, then we can smooth our decision boundaries, and even we can reduce the effect of outliers as well. So if you have some outliers in the data, then also you can reduce the effect of that particular outliers on our particular classification or prediction output. And what should be the k value? It's an obvious question, right? So we are trying to check for k nearest neighbors and what is the respective k value. So, and what it should be. So if it is too low, it will lead to overfitting, and if it is too high, it will lead to underfitting. So it should be an optimal one. So it's a sort of like the trade-off that is there. So we have to choose the optimal k value. And there are different strategies in choosing the k value. So you can do cross validation, or you can use some heuristics or some set of algorithms for finding the optimal key value. Yeah, so what is the logic of KNN? So suppose we have these different images that are present, and you have to somehow associate or classify this particular bird to this record. So we have these different records, right? So you can see like this is fish and this is lion, and this is the bird. So you have to associate this with the bird. So how do you do the classification or association here? For doing that, so whatever the categorical data or images or text, whatever is available with you, first you have to vectorize it, you have to convert it into vectors, and then you have to project it in a m-dimensional Euclidean space. So once you have done that, as you have projected your data into Euclidean space, then it will be numbers. Obviously it's a vector, so we can find the distance between these two vectors. So you have p1, p2, and so on. This whatever our North Carolina bird, right? That is one vector, and your dinosaur is one more vector. So you are going to calculate the distance between Euclidean distance between these two different vectors, and then you based on the distance metric, you are going to perform the classification. So this is how you know the elementary math, right? So this is how we are calculating the Euclidean distance part. So this is the calculation using equation using which you will perform the calculation to get the Euclidean distance between two different vectors or two different data points. And yeah, suppose if you have k equal to 1, so you are only checking for, this is your data, so this is your sample for which you have to associate. Now the question here is, do this particular sample belongs to blue or yellow class? So you have two classes, right? Blue and yellow, or circle, yeah, blue and yellow. So you have to associate it to some class. So this is a binary classification problem, that task that we have at hand, and you have only one voter here. So if you take the nearest neighbor here, so you can see that only blue is present. So now you can conclude or confirm that okay, this belongs to blue. Why? Because you have taken k equal to only one, right? So this is one type of, like, this is how you do it if k equal to 1. Suppose k equal to 3, you will try to check for three neighbors, three nearest neighbors. So here your cycle has increased, cycle boundary, and you can see the nearest neighbors here. So you have two blue and one yellow neighbor in the respective neighborhood or the circle that we have defined when k equal to 3. And the majority is 2, right? If you do a voting, so blue is majority. So obviously you can associate, or you can group this particular unknown sample into blue class. So it belongs to blue. So this is how basically a KNN algorithm works. And yeah, and basically when you are choosing that the k whatever the k value nearest neighbors, you have to make sure that it is always something odd number. So it is 1 or 3 or 5, like that. Why? Because if it is even, then there's a tie, there's a problem, right? That is the reason we are taking the odd number, so that whenever you are doing this association part, whatever the majority voting that we are doing, right? Suppose if it is three, obviously, like if two is if two are class A and one is class B, then you can tell that majority is class A. So there's a decision that we can take directly. But if it is four or six or something even, then if there's a tiebreaker, then you can also, you cannot associate a particular whatever unknown sample to a particular a class, right? As we have done it previously in these examples. So that is the reason k should be an odd number. And which data points are near to me. So to find that, there are different distances that we can take or that we can calculate, and but basically we are using something called this Euclidean distance. And if you want to calculate the distance between the points, suppose this is the direct distance that you have to calculate, then there's something called this Pythagoras theorem, right? With respect to that, this value will be the sum of squares of this and this. A square plus b square will be equal to your c square, and c is the value that we have to find out, right? So this is what the Euclidean distance, and this is how we are calculating the Euclidean distance as I have shown here. And yeah, so which data points are near to me? So this Euclidean distance we are using to calculate or find the distance data points that are near to the unknown sample that we are dealing with. So coming to the final algorithm, how it is going to work is, first you are going to load your data, and then you are going to initialize your k to your chosen number of neighbors. And for every example or for every new sample that is going to come with respect to the k samples neighbors, suppose if the k value is 3, then you are going to calculate the distance between the three neighbors, and whichever is the closest one, or how many neighbors. Suppose you have two neighbors, so two neighbors of class k and one neighbor of class b, then you are going to tell that we are going to use a voting procedure, and then with respect to the voting it receives in the classification problem, this is the highest one, right? So class A are two samples, class B is one sample, so class 2 is the majority, sorry, class 1 is the majority, so you're associating your unknown sample to class 1. So this is how the KNN basically does the classification part. But if it is regression, then what we are going to do is we are going to whatever the majority are there, right? So once we get the distances, we are going to sort it in ascending manner, and we are going to pick the first k entries, and for that particular k entries, you are going to take a mean of it, and that mean you are going to take it as your regressor output. So if you are doing regression, that will be your mean, and if you are doing classification, it will be your mode, in the sense like whatever the majority voting that you are referring to, right? If you do a mode of it, you will get that, and that will become your classification result. So this is how basically the KNN algorithm perform classification and regression. And how to choose the right case, so that is what the challenge behind in front of us, right? So how to choose our k value, and if you choose k to 1, which is a trivial one, then the predictions will be not so stable, and that is not a right thing to do. Why? Because if k equal to 1, then you are only checking one neighbor, which is not the case, right? So you cannot just go with the decision of one neighbor, so it doesn't make much sense. So as you are increasing your k value, what happens is some aggregation or the mean that we are taking, right? And also the voting procedures that happens, which is your aggregation or majority voting that we are doing. Because of that, we are taking into consideration the nearby samples as well, and the decision, when whatever the decision we are making, it is depending on the neighbors that are around us. So we are taking a majority voting of it, and we are doing some sort of ensembling with respect to the data points. So obviously, like your classification accuracy or whatever the prediction accuracy is there, it will increase as you increase your k value. But as you keep on increasing your k value, at some point you will observe that your accuracy start decreasing there. Then you have to understood that you have pushed your k value so far, and you have to stop there. So somehow you have to find a sweet spot of k, which is the optimal one. And yeah, we have to make sure that the k value is always an odd number, so to avoid the tiebreaker condition. And yeah, so if you are doing the KNN classification, if k equal to 1 and k equal to 5 and k equal to 25, you can see the decision boundary that is visualized. So as you keep on increasing your k value, your decision boundary is becoming smoother and smoother, right? So you can see here. So yeah, so that is what from underfitting to overfitting you are moving with respect to the k value. So k is a very important hyperparameter and the only hyperparameter that we have to look into when we are considering our KNN. And yeah, choosing the right case. So if you have this training error, with respect to the training error, if you see, for k equal to 1, training error will always be 0, because we are looking about only ourselves, right? So there is nothing we can classify or associate to. And as you are increasing your k value, the training error is also increasing, right? So you can see that. So this is with respect to the training error and the k value. And with respect to the testing error, which is important one, and with respect to which you are going to choose your k value, as you see, as you increase your k value in this particular example and for this data, you can see that as you are increasing, your loss validation error is decreasing. So the validation error is keep on decreasing, and at particular point, you can see again it started increasing, right? So there's a sweet spot here. So that is 10. So k equal to 10 is the optimal value for this particular data set. So for every data set, it will vary accordingly, and you have to keep on changing your k value and plot this kind of graph so that you can find the optimal k value for that particular data. So it's a validation error curve that we have plotted to know the optimal value of k. And this value of k we should use for all the predictions that we are referring to. So when k equal to 1, it will lead to overfitting of the boundaries, and as you keep on increasing your k value, it will finally lead to optimal k value. And what are the pros and cons of the KNN algorithm? Advantages is it is very simple, as you can see, and there are no much hyperparameters also, right? If you compare other algorithms, there are a lot of hyperparameters that we have to tune into, but here we have only k value that we have to look into, right? And coming to the disadvantages part, so it is obviously like significantly slower than the other algorithms that we are considering. Why? Because we are calculating the distance across all the samples, and we are finding the nearest neighbors, and we are doing all these different things, right? So that is the reason it will be slower compared to other algorithms. And also, as the number of samples increases, it will be difficult for this to cope up. So there is something called this curse of dimensionality, where as the dimensions keep on increasing, the distances that we are finding, or the nearest neighbor concept, everything will whatever the computational complexity is there, it increases significantly, and that leads to this curse of dimensionality issue, and you cannot use or calculate your KNNs, or the KNN algorithm cannot work in that particular case in higher dimensions. So that is the disadvantage of the KNN.